Hi class. So today we're going to continue with projectile motion and um, so when we left off last time we were working with velocities where they gave us in the problem they gave us the horizontal and vertical components of the velocity. So for example, if we had a velocity of let's say uh, 38 meters per second, they would tell us, well, that has a perfectly sideways component of velocity of something less than 38, maybe 30, and it's got a vertical component of velocity, and this component is going to be affected by gravity of something maybe like 15 meters per second. What we want to do now is explain to you how, because now in problems going forward, they're going to give us the initial velocity frequently enough, and they're going to give us some angle above horizontal, and they're going to want us to figure out exactly what is the horizontal component of the velocity and what is the vertical component of the velocity. And in order to do that, we're going to use these trig ratios. So many of you may have seen these already in math class. Some of you may not have. So we'll go over it. So what these ratios basically say is at some angle, and let's say 30 degrees. Let's use 30 degrees as an angle. So if I've got a triangle with 30 degrees at 30-degree angle in it, that we first of all we need to label the three sides of the triangle. So the side opposite the right angle, the longest side, is the hypotenuse. Okay, so the longest side is the hypotenuse. The side away from or opposite the angle is called the opposite side. So the length of this side we call the opposite side. And the side next to the angle, we call that the adjacent side. It's the side, what's called the leg of the triangle that is next to the angle. So we call this, the length of this side, the adjacent side. Okay, the adjacent side next to the angle. The side of the triangle that's far away from the angle is called the opposite side. And the basic idea is that I could make this triangle larger or smaller. So I could make this triangle bigger, let's say, as long as I keep the 30-degree angle. The ratio of the sides will stay the same, meaning at any angle, the ratio of, and let's do sine for now. Sine is the ratio of the opposite side to the hypotenuse. So the ratio of this opposite side to the hypotenuse will be the same as that ratio. This opposite side versus this hypotenuse side would be the same as the ratio of this bigger triangle, this longer opposite side to this longer hypotenuse side. So if I whether I used a smaller triangle or a bigger triangle, the ratio of these sides would be the same at a given angle at 30 degrees. So let's do an example. At 30 degrees, the sine of 30 degrees, the sine, I'll put it down here, the sine of 30 degrees equals 0.5. If we plug that into a calculator, we're going to get 0.5. And that equals the ratio of the opposite side. Sine is opposite over hypotenuse. The opposite side over the hypotenuse. So what that means is whatever, what this basically means is the opposite side is 50% of the hypotenuse. Always, no matter how big the triangle is. So at 30 degrees, the opposite side, the length of this side, will always be 50% of the length of this side. So if I make my triangle bigger, that ratio stays the same. The length of this opposite side, this long opposite side, would be 50% of this long hypotenuse here. Okay, so the ratio stays the same no matter how big the triangle is. Now this ratio is going to be different for each angle. Right? If I have a bigger angle, let's say 80 degrees, okay, obviously the opposite side is no longer going to be 50% of the hypotenuse. The opposite side is going to be a larger percentage of the hypotenuse. But if I make this triangle bigger, the ratio still holds true. The ratio of the opposite divided by the hypotenuse will still be the same. Okay, so we're going to use these things to solve this problem for us. Okay, so there's three ratios that you need to know. Sine is opposite over hypotenuse. So we just as a reminder of that, we say SOL. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Cosine adjacent over hypotenuse. And tangent is opposite over adjacent. So it's just the ratio of different sides of the triangle. So tangent is opposite over adjacent. Okay, so let's just do some examples and it will become more apparent. So first problem. Here we have a cannonball is launched diagonally with a velocity of 34 meters per second. Okay. And as we said in the last video, we're really not going to be using a diagonal velocity in any of our analysis. We're always going to be using the upward component of the velocity and the sideways component of the velocity. So what we need to figure out is, given this velocity and given that angle, what is the sideways component of the velocity and what is the upward component of the velocity. So basically we just form a right triangle and we figure out these sides. Okay, so let's say we want to, here's our angle. This is our angle here. This is 73 degrees from the horizontal. All right, so this is definitely our opposite side. And this down here, the side that's touching the angle, is definitely our adjacent side. And obviously, this is the hypotenuse side of the triangle. So this is a right triangle, adjacent, opposite, and hypotenuse. Okay, so we want to figure out what is the length of this opposite side of the triangle, or what is the velocity in the vertical direction. So in order to figure out the opposite side, we know the hypotenuse. So we're going to say to ourselves, which trig ratio involves opposite and hypotenuse? We're going to say, I know that one. That's sine, right? Sine of an angle is equal to the opposite over the hypotenuse. Okay, so our angle in this case is 73 degrees. So we can plug that in for our angle. The opposite side is what we're trying to figure out. This is the velocity in the vertical direction. So I'd say the velocity in the vertical direction. Okay, we use v for velocity, little v underneath it as an indication that this is the velocity in the vertical direction. Okay, so this side of the triangle represents the velocity in the upward direction. Okay, over the hypotenuse, and the hypotenuse is the velocity coming out of the cannon. So it's 34 meters per second. All right, so now how do I solve this? Well, I can just cross multiply this. You can think of this as being over 1. Just cross multiply. So we get 34 sine 73 equals 1 times the vertical velocity. So that's the vertical velocity. Okay, now we have to get this, we need to plug it into our calculator. So let's go to our calculator. And what do we have here? 34 sine 73. Okay, so we go to our calculator. And we need to make sure we're in degree mode. Over here, there's two ways to handle angles. We need to make sure we're in degree mode, so make sure degrees is turned on or highlighted. Okay, so we said 34 times sine of 73. If I recall that correctly, yes, 34 sine 73. Okay, and then we just put that into our calculator, and we get an answer, 32.51. 32.51, or we could probably get away with 32.5. Okay, so 32.5, and I'm I'm just going to write that down. So 32.5. All right. And I'm just also want to highlight what is just sine 73 all by itself. Sine 73 all by itself is 0.96. So sine 73 is 0.96. Okay, so let's go back and answer our question. Okay, so two things I want to point out. The first thing was when we plugged sine 73 into our calculator, we got 0.96. And what does that mean? That means the opposite side is 0.96 times the hypotenuse, because this is the ratio of the opposite over the hypotenuse. This basically says the opposite side is 96% of whatever the hypotenuse is. Okay? So you can think of it that way. You should think of it that way, that the sine of 73 is telling us that at 73 degrees, the opposite side of this triangle is 96% of the hypotenuse. So when we multiply our hypotenuse times 96%, we get, or 34 times 0.96 is 32.5. Okay, so that's how we figured out that the vertical velocity is 32.5. So we plug that in here, 32.5 meters per second. That's the velocity in the upward direction. Okay. Now, how do we figure out what the velocity is in the x direction, the horizontal direction, the sideways direction? Well, this is the adjacent side. So which trig ratio involves the adjacent side? And we know the hypotenuse to begin with. So let's say adjacent and hypotenuse. Well, that would be cosine. The cosine of an angle is equal to the adjacent side, the ratio of the adjacent side to the hypotenuse, or the adjacent side divided by the hypotenuse. Okay, well in this case, the adjacent side is going to tell us the velocity in the horizontal direction. Okay. So the velocity in the horizontal direction. The hypotenuse, again, is our initial velocity, 34 meters per second. And we have cosine of our angle. Okay, so let's look up what cosine 73 is. And then again, to solve this equation, we can simply cross multiply again. Pretend this is over 1, and we're just going to cross multiply. So we're going to get 34 cos 73 equals velocity horizontal. So let's go back to our calculator, and we want 34 cos 73. Okay, so we're going to say, first of all, we're going to say 34 cos 73, cosine 73, and we get 9.49. So let's write that down. Our velocity in the horizontal direction is 9.94 meters per second. Okay, and just for sake of discussion, let's look at just cosine of 73 all by itself, which is 0.29. Okay, so let's go back to our problem. And let's write down our answers. Okay, so we plugged into our calculator 34 cos 73, and we got 9.94 meters per second. So that is our horizontal velocity. This sideways velocity here is 9.94 meters per second. That's the velocity. That's not going to change because it's purely horizontal. Gravity does not affect this velocity. And what did we say cos 73 was? Cos 73 all by itself, cosine of 73 degrees was 0.29, which means that this side of the triangle is 29% of the hypotenuse. So these ratios basically tell you what portion of the hypotenuse, what percentage of the hypotenuse is my opposite side and what portion or what percentage of the length of the hypotenuse is my adjacent side. Okay? So this is adjacent, cosine is adjacent over hypotenuse. So the adjacent side is 29% of the hypotenuse, and the sine is opposite over hypotenuse. So this tells us that the opposite is 96% of the hypotenuse, or 0.96 times the hypotenuse. Okay, and then once we have this, we can solve the problems fairly easily, right? That we know this portion of the velocity is going to be affected by gravity. This portion is not going to be affected by gravity. Again, so you want to think of this again as a triangle. Okay, the initial velocity coming out of the cannon is 34 meters per second. It came out at an angle of 73 degrees above the horizontal. Okay, this portion of that velocity is the sideways velocity or horizontal velocity, which we computed to be 9.94, about 10 meters per second in the horizontal direction. And in the vertical direction, the velocity was 32.5 meters per second. Okay, this is going to be affected by gravity. This is not going to be affected by gravity. All right, let's try and do one or two more, and hopefully that will explain things. Okay, here's another problem. This time it's a 25-degree angle. This problem is a little bit different. Now they're not telling us the initial velocity coming out of the cannon. They're telling us the initial vertical velocity. Okay, so they're telling you what is the velocity in the upward direction. Okay, so they're saying this portion of the velocity, okay, this is 24 meters. This is 24 meters per second. Okay, and they're not telling us what the hypotenuse is. So we need to figure out what the other two sides of this triangle are. So they didn't give us the initial velocity. They gave us the initial vertical velocity. We can plug that in right away. They're asking us to find the horizontal velocity and the just initial velocity overall. All right, well, again, they give us this angle. This is clearly the opposite side of the triangle, the vertical. Vertical means up and down. The vertical velocity is clearly the opposite side of the triangle. Okay, so we've got our opposite side of our triangle is 24. We've got our angle, which is 25 degrees. Okay, this 24 meters per second is the opposite side. This side next to the angle is the adjacent side, and this side over here, across from the right angle, is the hypotenuse. All right, so if we want to find the hypotenuse, we can use the trig ratio that involves opposite and hypotenuse, which is sine. So we can say that the sine of an angle is the opposite over the hypotenuse. The angle in this case is 25 degrees. So we say sine of 25 degrees equals the opposite. We know what the opposite is, 24 meters per second. And we're trying to figure out the hypotenuse. Okay, now again, we can cross multiply, pretend this is over 1. So we get h sine 25 equals 24. And then we want to solve for the hypotenuse, which is the initial velocity. And so we divide both sides by sine 25, and we get hypotenuse equals 24 divided by sine 25. And the hypotenuse represents the initial velocity, not the initial velocity, not any particular component of the initial velocity, but the initial velocity coming out of the cannon. Okay, so we can solve for that. So again, we use our calculator. So 24 divided by sine 25. So we go to our calculator and we say 24 divided by sine 25. Make sure we're in degree mode, which we are, and let's call this 56.8. Okay, so then we go back to our problem. And what did we say it was? 56.8? 56.8, yeah. Okay. And boop. So then we have our answer. Hypotenuse equals 56.8. So this is 56.8 meters per second. So the initial velocity coming out of this cannon was 56.8 meters per second at an angle of 25 degrees above the horizontal. So our initial velocity, now we can plug that in, 56.8 meters per second. Okay, so now we know two sides of the triangle. 56.8 meters per second coming out of the triangle, coming out of the cannon. That has a vertical velocity of 24 meters per second. We want to figure out the horizontal velocity as well here. So what can we do? And one way certainly to do that would be to use cosine, right? Because we know this is the adjacent side, this is the hypotenuse. So let's do that. Let's do, well, actually, let's do another. Let's do tangent, because we know the opposite is 24. This is the adjacent side. Okay, so let's do tangent. Tangent of an angle is the opposite over the adjacent. The adjacent is what we're trying to find. We're trying to find this portion down here. We're trying to figure out what is the sideways component of the velocity. What's the velocity in the x direction, in the horizontal direction? Okay, so we would say tangent of 25 degrees equals the opposite. Now the opposite side we know is 24. That was given to us in the problem, 24 meters per second, over the adjacent side. The adjacent side is this. It's the horizontal velocity, or the velocity in the x direction. Okay, so now, again, we think of this as being over 1. We cross multiply. You get Vx, velocity in the x direction or the horizontal direction. Tan 25 equals 24. And then divide both sides by tan 25. So you get velocity in the x direction is 24 over tan 25. And we can now use our calculator. So let's go do that. So it's 24 over tan 25. So we go to our calculator. So 24 divided by the tangent of 25 degrees. And that equals 54.46. 51.46. We could probably call that 51.5 degrees. Okay, so then we come back 51.5 degrees, and we say, not 51.5 degrees, 51.5 meters per second. We say our velocity in the x direction is 51.5 meters per second, so our horizontal velocity is 51.5 meters per second. Okay, so in this case, our triangle was, here's our right triangle. Okay, so we had an angle of 25 degrees down here. Okay, they gave us the opposite side was 24 meters per second. We figured out that the hypotenuse was 56.8 meters per second. And the adjacent side over here, giving us the horizontal velocity, was 51.5 meters per second. Okay, so now that we know what is the vertical velocity, we know this is going to be affected by gravity. This horizontal velocity is not going to be affected by gravity, and we can solve problems using those two components. All right. We'll do a couple more problems, but I'll stop the video here, and then we'll show some more practice problems shortly.